Perseverance, nicknamed Percy, is a car-sized Mars rover designed to explore the crater Jezero on Mars as part of NASA's Mars 2020 mission. It was manufactured by the Jet Propulsion Laboratory and launched on the 30th of July 2020 at 11:50 Coordinated Universal Time. Confirmation that the rover successfully landed on Mars was received on the 18th of February 2021 at 20:55 UTC. As of the 21st of March 2021, Perseverance has been active on Mars for 30 sols since its landing. Following the rover's arrival, NASA named the landing site Octavia A. Butler Landing. Perseverance has a similar design to its predecessor rover, Curiosity, from which it was moderately upgraded. It carries 7 primary payload instruments, 19 cameras, and 2 microphones. The rover is also carrying the mini helicopter Ingenuity, or Guinea, an experimental aircraft and technology showcase that will attempt the first powered flight on another planet. The rover's goals include identifying ancient Martian environments capable of supporting life, seeking out evidence of former microbial life existing in those environments, collecting rock and soil samples to store on the Martian surface, and testing oxygen production from the Martian atmosphere to prepare for future crewed missions. The Perseverance rover has 4 science objectives that support the Mars exploration programs. Science goals. Despite the high-profile success of the Curiosity rover landing in August 2012, NASA's Mars exploration program was in a state of uncertainty in the early 2010s. Budget cuts forced NASA to pull out of a planned collaboration with the European Space Agency which included a rover mission. By the summer of 2012, a program that had been launching a mission to Mars every 2 years suddenly found itself with no missions approved after 2013. In 2011, the Planetary Science Decadal Survey, a report from the National Academies of Sciences, Engineering, and Medicine containing an influential set of recommendations made by the planetary science community, stated that the top priority of NASA's planetary exploration program in the decade between 2013 and 2022 should be to begin a Mars sample return campaign, a 3-mission project to collect, launch, and safely return samples of the Martian surface to Earth. The report stated that NASA should invest in a sample caching rover as the first step in this effort, with the goal of keeping costs under $2.5 billion United States dollars. After the success of the Curiosity rover and in response to the recommendations of the Decadal Survey, NASA announced its intent to launch a new Mars rover mission by 2020 at the American Geophysical Union Conference in December 2012. Though initially hesitant to commit to an ambitious sample caching capability, a NASA-convened science definition team for the Mars 2020 project released a report in July 2013 that the mission should select and store a compelling suite of samples in a returnable cache. The Perseverance design evolved from its predecessor, the Curiosity rover. The 2 rovers share a similar body plan, landing system, cruise stage, and power system, but the design was improved in several ways for Perseverance. Engineers designed the rover wheels to be more robust than Curiosity's wheels, which have sustained some damage. Perseverance has thicker, more durable aluminum wheels, with reduced width and a greater diameter, 52.5 centimeters. The arm hosts an elaborate rock coring and sampling mechanism to store geologic samples from the Martian surface in sterile caching tubes. There is also a secondary arm hidden below the rover that helps store the chalk-sized samples. This arm is known as the Sample Handling Assembly, and is responsible for moving the soil samples to various stations within the adaptive caching assembly on the underside of the rover. These stations include volume assessment, imaging, seal dispensing, and hermetic seal station, among others. Due to the small space in which the SHA must operate, as well as load requirements during sealing activities, the sample caching system is the most complicated, most sophisticated mechanism that we have ever built, tested and readied for spaceflight. The combination of larger instruments, new sampling and caching system, and modified wheels makes Perseverance heavier, weighing 1,025 kilograms compared to Curiosity at 899 kilograms. A 14% increase. The rover's radioisotope thermoelectric power generator of plutonium-238 oxide as its power source. The natural decay of plutonium-238, which has a half-life of 87.7 years, gives off heat which is converted to electricity, approximately 110 watts at launch. This will decrease over time as its power source decays. The MMRTG charges two lithium-ion rechargeable batteries which power the rover's activities and must be recharged periodically. Unlike solar panels, the MMRTG provides engineers with significant flexibility in operating the rover's instruments even at night, during dust storms, and through winter. The rover's computer uses the base system's RAD 750 radiation-hardened